we are going to look at mechanics, exam questions under mechanics. This will be our first question under mechanics. It is velocity, time, graph. Okay? Velocity against time. It is very important to understand mechanics because it is examined. In that discipline of physics, you find this question. So, the following is a velocity time graph. So, this is our velocity time graph. We have this axis. What do we call this axis? X-axis. Is what? X-axis. This is the x-axis. This is where time is indicated. And this is the y-axis, where velocity is indicated. So, the question is as follows. What was the maximum velocity for the journey? B. Calculate the acceleration in the first 5 seconds. C. Calculate the distance covered in 10 seconds. So, we'll look at these questions critically. Let's start with the first one. What was the maximum velocity for the journey? So as you can see, the velocity is from this point. This is the 0 point of the graph. Okay? So you can see this line going straight up to this point. Okay? You know what it means. From here to there. What is represented by this graph in the What is happening from here to there? There is an acceleration, right? From 0 meter per second to what? 30 meters per second. Then from this point to this point, what is happening?
Acceleration is 0.
The acceleration is 0. Very good. Or we can say that the velocity is constant. It's not changing. If the velocity is constant, it means from this point to this point where there is constant velocity, it means there is 0 acceleration. There is 0 acceleration because acceleration is the rate of change of velocity. So if the velocity is not changing, then it means this object is not accelerating. It means the acceleration is 0. So there, the acceleration is 0 meters per second squared. From this point to this point, there is 0 acceleration because the velocity is not changing. Now, let's look at our question. What was the maximum velocity for the journey? So when they say maximum velocity, they mean final velocity. Okay. So what was the maximum velocity? The final velocity reached for this journey was what? Fumba? 30 what? Yes?
30 meters per second.
Correct. It was 30 meters per second. So from 0 to 30. Okay? So from 0 to 30, this is the final velocity. This is the maximum velocity reached. Because we don't have any velocity going beyond 30. So this was now maintained. Okay? It was maintained. 30 was maintained. And from this point to this point, what is happening here? The velocity started to decrease. Okay? We call this as deceleration. Okay? Deceleration. So this point is showing deceleration. The other term we can use for deceleration is retardation. Retardation or negative velocity. Negative acceleration rather. Negative acceleration. So, our first question, what was the maximum velocity for the journey? What should be the answer there? What was the maximum velocity? 30 meters per second. As simple as that. Because the final velocity from 0 to 30. That's the final velocity. Next question, we have calculated the acceleration in the first 5 seconds. From 0 second to 5 seconds. What was the acceleration this object. Acceleration is the rate of change of velocity. So in the first 5 seconds, this is where the 5 seconds is. And what was the acceleration in the first 5 seconds? How do you calculate this acceleration? So to calculate this acceleration in the first 5 seconds, we are going to use the formula for acceleration. So we say A acceleration is equal to V minus V is final velocity, U is initial velocity over time taken. So acceleration is equal to, in the first 5 seconds, the final velocity was what? 30 meters per second minus the initial velocity. The velocity started with 0. Great. So 0 meters over time taken by 5 seconds. So we are going to have 30 over. This will give us what? 6 meters per second. Don't forget to show this square because it shows that you are talking about acceleration. If you leave this square, you can be penalized. Is that clear? Next question we have: calculate the distance covered in 10 seconds. So 10 seconds from the 0 second here. What distance was covered? This is very important, learners. Calculating the distance on a velocity time graph. To some, it becomes a challenge to calculate the distance. What are you supposed to do when you are calculating the distance on a velocity time graph? To calculate the distance on the velocity time graph, you need to consider the area under graph. The area under graph. Okay? The area of this graph. Because we are given from 0 second to 10 seconds. So the area of this graph, that will be your distance. So there are 2 ways by which you can calculate the distance. One, you consider the shapes in the time frame that you are given from 0 to 10. Okay? You can see the shapes which are in that graph from 0 second to 10 seconds. Which shapes can you identify? Yes, right on. Triangle. Okay, very good. So we have this triangle. Okay, and then the other shape we can identify is what? Priscilla? The square. Is that a square? No. It's a what? A rectangle. Okay, very good. Rectangle. So this is a rectangle. So there are 2 shapes. In 10 seconds, from 0 to 10 seconds, you can see 2 shapes. So calculating the distance will be very easy for you. You have to calculate the area of these shapes. You calculate the area of the triangle plus the area of a rectangle. Is that clear? Yes, sir. So it is important to know the formula. The formula for area of a triangle, this one, and also the formula for area of a rectangle. Then you add the 2 areas. That's distance. So let's see how we can do it. Can I point at someone to come and calculate the area of this triangle? We start first of all with the triangle, then we shall come to the rectangle. So we okay. Area. We have 2 shapes. We have shape A and we have B. Okay. So for shape A, we have a triangle. So we shall find area of triangle. Okay. Let's see from this one.
So let's calculate the area of a triangle. So the area of a triangle is calculated by the formula, which is area should be equal to half base height. This is the formula that we use to calculate area of a triangle. So we just substitute in the formula. So the base from 0 to 5, this is the base, and then the the height from this point to this point, that is the height. So we say the base you get from 0 to 5, that is 5. Then say area equal to half the base, which is 5 multiplied by the height from here, from this point to this point is 30 meters. So we say multiplied by 30. So our area equal to 5 multiplied by 30, that is 150 over 2. Then 150 divided by 2 is 75. So 75 is the area of the diagram.
Okay, thank you so much. So it's very simple. The knowledge that you have in mathematics on how to calculate the area of triangle. As he explained, area of triangle A is equal to half the base by height. Okay? The base is the distance from here. The height is the distance from here. So this is our base, and this is our height. So base is from 0 to 5, it's 5. This is the 5 that is here. And then here, right here, area is equal to half BH. Area is equal to half BH. Area of triangle is equal to half BH. So area is equal to, what's the base?
5
Times the height.
8.
Okay. 2 there.
1
2 there.
15.
Is what?
15.
15.
Yes, sir. Yes, sir.
Then you multiply 5 by 15. What do you get? 75 square meter. So in this 75 square meter will show you the distance. So the distance covered from 0 to 5 for the area of triangle was 75 meters. Now we come to the other shape, shape B. Shape B is the rectangle. You need to calculate the area of a rectangle. This time I need the girl to come and show us how to calculate the area. Rectangle. Shape B, that is rectangle. Yes. Rose. Okay, area of the rectangle is equal to L times BB. Okay? Length times BB. Okay? So the longest distance is the length. So from here to there is 30. That's our length. From here to there is what? It's 5. So you get the difference. 10 minus 5. So we have here 5. Okay? Our big is 5 there. So area is equal to length is 30. From here to there times 5. What is 30 times 5? 150 square meter. Therefore, the distance just for the rectangle was 150. Now, the total distance in 10 seconds from 0 to 10 will be the addition of the area of triangle and the area of rectangle. So we add. We are going to get what was the area for the triangle? 75. Okay, and the distance was 75 meters plus the other distance is 150 meters. What's the answer there? 225 meters. Okay, that is the total distance from 0 to 10 seconds. If they say the total calculates the total distance for the whole journey, you have to include the other shape which is remaining. What other shape is remaining? Triangle. Can you see this triangle?
Yes.
So you need to calculate the area of this triangle, then you add to this value to calculate the total distance for the whole journey. Well, class, it was a nice time having you. Do you have any questions?
Here's our calculating the distance covered in 20 feet. Calculate and use it a diagram.
Very good. There's also another method you can use. It's using the trapezium formula. Okay? Because this shape, the triangle and the rectangle combined will form what you call trapezium. Okay? Trapezium. So you can also use area of trapezium. You can simply use that one if you want. You can use the formula for area of trapezium. The trapezium consists of a triangle and a rectangle, or a square combined with a triangle. Okay. So, look at this area of trapezium. Queen, what's the formula for area of trapezium?
T is equal to H over 2 of A plus B.
What did you say? Area of trapezium?
Equal to H over 2.
Is that clear?
Yes, sir.
Is that correct? So area of trapezium is equal to half A plus B times height. Okay? Half A plus B times height. A represents one of the distances or length of that rectangle or square. Okay? So for instance, the distance from here to there can be represented by letter A, and the distance from here to there can be represented by letter B. So we use letter B. So this one is represented by letter B. So in this case, we shall say area of trapezium is equal to half. What's the distance of A from here to there?
5.
It's 5. Okay. 5 plus the distance of B from here to there.
10.
It's 10 times the height.
8.
8. Okay. So this will be area is equal to 5 plus 10. 5 plus 10? 15. This means you have 1 times 15 times 8. It's 450.
Yes, sir. It's 450.
450 over 2. So 1 times 15 times 30 is 450. And then we have over 2. What do we get there? 2 square. Therefore, the distance in 10 seconds is 2.5. Okay, so you can still come to the same answer. Thank you, class. It was a nice lesson and nice time to have you. See you in the next lesson.
Thank you, sir. Yes, sir.
Gracious.